Hello, the topic we're discussing today is T-test. The objectives of this module are to enable one to calculate the T-test, to use T-test to find out the significance of difference between means, to know where to apply T-test. Most of the psychological experiments are conducted on more than one group of subjects. In such instances where data are collected from two groups of subjects, one group is exposed to the experimental condition while the other serves as the control group. Alternatively, experiments are also conducted on just one group of subjects under two different testing conditions. The question is whether there exists a difference in the mean performance of the two groups or two testing conditions. If a difference is found, then does it hold same for the population from which the samples were taken? Basically, we ask whether a difference between the two sample means reflects a true difference or whether it was due to sampling error. By taking into account the means of the two groups, we can say whether there exists a difference between the two groups. Because we know that the means of two groups randomly drawn from the same population are not necessarily identical, any difference could possibly be attributed to sampling error or chance. To be statistically significant, the difference must be greater than that attributable to sampling error. We use T-test to find out the significance of difference between two means. Computation of T involves calculating the ratio between the experimental variance, that is, the difference between two means, and error variance, that is, the sampling error factor. The significance of difference will depend both upon the size of the obtained difference and upon the variability of the means being compared, as given by the standard error of the difference between the two means. There are different types of T-test, but in this discussion, we will focus only on independent samples T-test and secondly on dependent samples T-test, which is also known as paired samples T-test. Both the tests are used to find out significant differences between groups. But the independent samples T-test assumes that the two groups are not related to each other, while the dependent samples T-test or paired samples T-test assumes that the two groups are related to each other. A dependent samples T-test or paired samples T-test would be used to identify differences within group, while the independent samples T-test would be used to examine the differences between groups. So, when we administer a test on the same group of subjects twice or apply two different tests on them, then we calculate the T-test, which is called paired samples T, dependent samples T, or correlated T. The paired T-test is also used when we compare two matched groups. However, before applying the T-test, one must be aware of the assumptions the T-test makes about the data set. T-test assumes that the research study involves the estimation of at least one variable. Secondly, the groups are independent and that nothing in one group helped to determine who was in the second group. To calculate the difference between two related groups, a paired T or a correlated T-test can be used. Fourth, variables are measured in interval or ratio scale. Fifth, the sample was selected randomly. And finally, each of the populations is normally distributed with the same variance. So when do we apply the T-test? The t-test, which is a parametric test of significance, is quite robust and powerful. It is used when we want to compare two sets of scores provided by different participants, the same participants, or matched participants. Prior to calculating the t-test, one must also be aware of certain concepts that we will now consider. The first concept that we're going to look at is the levels of significance. The rejection or acceptance of a null hypothesis is based upon some level of significance, which is known as the alpha level. The 5% or 0.05 alpha level and 1% or 0.01 alpha level of significance are often used as a standard of rejection. Rejecting a null hypothesis at 0.05 level indicates that a difference in means between the experimental and control groups would have resulted from sampling error in less than 5 out of 100. This indicates a 95% probability that the difference was due to the experimental treatment rather than due to sampling error. Rejecting a null hypothesis similarly at 0.01 level indicates that a difference in means found between the experimental and control groups would have resulted from a sampling error in less than 1 out of 100. Generally, these significance levels are written as shown on the screen. P is the symbol used to denote this level of significance, so we write significance levels as P less than 0.05 or alternatively P less than 0.01. The second concept we're going to consider is the two-tailed and one-tailed tests of significance. Let's first look at two-tailed or non-directional test of significance. Suppose we had a research question which asked, is there a significant difference between boys and girls with respect to memory? The hypotheses would be as follows. The null hypothesis, denoted by the symbol capital H with a subscript of 0 or O, would read, there is no significant difference between boys and girls with respect to memory. While the alternative hypothesis, symbolized by capital H with a subscript of capital A or capital H with a subscript of 1, would state there is a significant difference between boys and girls with respect to memory. Here we are stating that a difference will be found, although we do not specify what kind of difference, whether boys or girls will score better. We now consider the one-tailed or directional test of significance. The research question we had considered earlier can now be changed to, do boys score significantly higher than girls with respect to memory? The hypotheses would also change accordingly. The null hypotheses would state, boys do not score significantly higher than girls with respect to memory. The alternative hypothesis would read, boys score significantly higher than girls with respect to memory. As you will note, for this alternative hypothesis, we are predicting the direction of difference by stating that one group will score higher than the other group. The third concept we are going to look at is degrees of freedom, given by the symbol df. The degrees of freedom means the freedom to vary. The number of degrees of freedom in a distribution is the number of observations or values that are independent of each other. Suppose we have 4 scores and the mean of these scores is 20. The first 3 scores are free to vary or to have any value, but the 4th score must have a specific value so that the mean will be 20. For example, suppose we have 3 scores, 18, 16 and 22. Then the 4th score must be 24 so that the mean is equal to 20. Hence, degrees of freedom will be given by the formula df equals to n, which refers to the number of observations, minus 1. Since we had 4 scores, so the degrees of freedom would be equal to 4 minus 1 equals 3. The last concept we're going to consider is the types of error. Type 1 error results when we reject a null hypothesis that is really true. With tests of difference, this means that you say that there was a difference between the groups when there really was no difference. The probability of making a type 1 error is the alpha level you choose. If you set your probability or alpha level at p less than 0.05, then there is a 5% chance that you will make a type 1 error. You can reduce the chance of making a type 1 error by setting a smaller alpha level, such as p less than 0.01. However, the problem with this is that as you lower the chance of making a type 1 error, you increase the chance of making a type 2 error. So what is a type 2 error? A type 2 error constitutes the failure to reject a null hypothesis that is false. With tests of difference, this means that you say that there was no difference between the groups when there really was one. We will now learn how to calculate t-test with an independent group design. The basic idea for calculating a t-test is to find out the difference between the means of the two groups and to divide it by the standard error of the difference, which is the standard deviation of the distribution of differences. On the screen, you will find a table with the scores of two groups of subjects tested with one variable. We are going to determine whether the mean of group 1 and the mean of group 2 differ significantly from each other. Let us take a look at the labels for the columns in the table. The column group 1, denoted by the symbol capital X, gives you the scores of 7 subjects in group 1. The column group 2, denoted by the symbol Y, gives you the scores of 7 subjects who were in group 2. X square gives you the square of the scores of each of the subjects in group 1. Y square is the square of each of the scores of the subjects in group Y or group 2. The formula for calculating t-test for an independent group design here is T equals mean of X minus mean of Y divided by the standard error of mean difference. To calculate the standard error of mean difference equals the standard error of mean X squared plus the standard error of mean Y squared root over. Standard error of mean X or standard error of mean Y will be equal to standard deviation divided by root of n. The procedure for computing the independent t follows these steps. Step 1. Find out the mean of group 1, which will be equal to 20. Step 2. Find out the mean of group 2, which will be equal to 27. Step 3. Subtract the mean of group 2 from the mean of group 1, and this will be equal to 20 minus 27, which will give us a value of minus 7. Step 4. Find out the standard error of mean of group 1 and of group 2 by using the formula standard deviation divided by root of n. So the standard error of mean X will be equal to 3.21 divided by root of 7, which is equal to 1.21. Standard error of mean Y will be equal to 5.45 divided by root 7, which is equal to 2.06. Step 5. To find out the standard error of mean difference, we first add the standard error of mean x squared with standard error of mean y squared, which will be equal to 5.70. Step 6. We take the square root of the result we obtained from step 5, and this will give us a value of 2.38. Step 7. We divide the result we obtained from step 3 by the result we obtained from step 6 to get the value of t. And the value of t here is minus 2.94. Please note that a plus or minus sign associated with t ratio indicates the direction of the difference between the means. In this case, the mean of group 2 was greater than that of group 1, and therefore we obtained the minus sign. However, in the calculation of t ratio, the numerator in the formula is represented as the difference between mean 1 and mean 2. This is written as m1 minus m2. The symbol between m1 and m2 suggests that the difference will always be positive, so that t ratio does not carry the minus sign. But at the time of interpretation of the value of t ratio, the researcher takes into consideration the mean of the group which is higher than the mean of the other group, while drawing the conclusion on the basis of the t ratio value. The p-value remains the same in either direction. To find out the significant difference of group means, we need the degrees of freedom. This will help us to compare the obtained t-value with the critical value. If the t-value is greater than the critical value, regardless of the sign plus or minus, the null hypothesis is rejected. The degrees of freedom for this example are n1 plus n2, which refers to the number of observations in group 1 plus the number of observations in group 2. So we have n1 plus n2 minus 2. Since we had 7 subjects in each of the groups, so we have to do 7 plus 7 minus 2, which gives us a value of 12. The obtained degrees of freedom will be used to find out the critical value. But before going to the critical value, it is important to see whether we are using a one-tailed or two-tailed test of hypothesis. If the difference is in a particular direction, then we use a one-tailed test of hypothesis. If the direction is not clear, then we use a two-tailed test of hypothesis. For this example, we are using a two-tailed t-test. To identify the critical value, we refer to the table shown on the screen. The critical value for 12 degrees of freedom at alpha equals 0.05 is 2.18. Our obtained t-value of 2.94 is greater than the critical value, which is 2.18. So, we reject the null hypothesis and state the following. There is a significant difference between the two groups. And how do we represent the result we obtain from the t-test? We write it as follows. A small t followed by brackets in which we write the degrees of freedom. For this example, we had found that the degrees of freedom would be 12. And so we write t followed by 12 in brackets is equal to 2.94, comma p, which represents the level of significance. So p is less than 0.05. When we administer a test on the same group of subjects twice or use two different tests on them, then we calculate the t-test, which is called correlated t. Consider the table on the screen which shows the scores of a group of subjects in a mathematical test under stress and non-stress conditions. We will examine whether scores in the two conditions differ significantly or not. To quickly explain the labels for the columns in the table, the first column, labeled subjects, shows you that there were 10 subjects in this design. The second column, stress, given by the capital X letter, shows you the scores of the 10 subjects on the mathematical test in the stress condition. The third column, labeled non-stress, denoted by the symbol capital Y, shows you the scores of the same subjects on the repeated mathematical test under the non-stress condition. The fourth column, capital D, gives you the difference between the X and the Y scores for each of the subjects. The last column, D squared, is the square of the difference between X and Y scores for each of the subjects. The calculation would be done as shown on the screen. The formula for calculating t-test for a dependent group design is equal to the sum total of difference between X and Y given by sigma d divided by n into sigma d squared minus sigma d whole squared divided by n minus 1 root over. Please note that sigma d squared stands for sum total of the d squared column, while sigma d whole squared is the square of the sum total of the d column. Accordingly, we apply the formula to our problem. Therefore, t will be equal to minus 13 divided by 10 into 127 minus 13 squared divided by 10 minus 1 root over. And finally, we obtain the t value as minus 1.18. Please note that a plus or minus sign associated with t ratio indicates the direction of the difference between the two testing conditions. In this case, the scores in the non-stress condition were greater than those in the stress condition, and therefore we obtained the minus sign. The p value remains the same in either direction. If the same participants serve in both treatment conditions, or if the participants are matched, then the degrees of freedom for the t-test are given by the formula n minus 1. So here the degrees of freedom would be 9, since the number of subjects were 10. From the table, we note that the critical value of 9 degrees of freedom at alpha equal to 0.05 is 2.26. Since the obtained t value of 1.18 is lesser than the critical value 2.26, we retain the null hypothesis that the scores do not differ significantly in the two conditions, and we can show the results as follows. T in brackets 9, which represents 9 degrees of freedom, is equal to 1.18, which is the t value, comma ns, which represents non-significant. This implies that there is no significant difference in the performance of the group on the mathematical test under stress and non-stress conditions. To summarize, we have understood that the statistical measure called T-test is used to find out the difference between two groups or two testing conditions. By taking into account the means of the two groups or two testing conditions, we can infer whether there exists a difference or not between two groups or two testing conditions. We have seen two types of t-test. The independent samples t-test, which is used when we want to find out the significance of difference between the means of two groups that are not related to each other. The dependent samples t-test, paired samples t-test or correlated t-test is used when we have a single group or a matched group. Here, we would intend to find out the difference between two testing conditions. We also looked at the concepts relevant to calculating the t-test, such as levels of significance, two-tailed and one-tailed tests of significance, degrees of freedom and types of error. We learnt how to apply the formulae for independent and dependent group design. Therefore, the t-test, which is a parametric test of significance, is quite robust and powerful in helping us to understand whether two groups or two testing conditions differ from each other and whether the difference is significant or not.